Yes, I'm Casper, and a few months ago, I think, Chris mentioned that he would like to put on this challenge, and I immediately outlined exactly the only way that the infrastructure should be set up, and of course that was a silly thing to do because now I was responsible for implementing all of it for my sins. So I couldn't resist adding this quote from CERN's homepage, which is, well, I think effectively the biggest problem with running a competition like this, and dare I say it, MIC in general, is we have many talented scientists, which is wonderful until you have a non-scientific problem. So apologies to those who find the engineering side of things boring. I'll try to keep this super brief and interesting. So effectively, from a participant perspective, I think these are the components required. And first off, there had to be a way for people to register their interest, and also some template code that we give them that they can fill in, and raw training data that Chris mentioned that he had to put together, and a way for people to submit code. How do they do that? Do they send me a zip file of their code? Ideally, there should be an automated process for running all of their code immediately on a standardized piece of hardware, some GPUs, so that all teams are on the same footing. Ideally, they get immediate feedback, so if there are any bugs, they can immediately fix it. And maybe we even put results live on some website, on some sort of leaderboard, and then of course once submissions close, we need to release test data, and I need to run through all of the submissions again, but using the different data sets. So I would like to say I think one of the main results of this whole thing is Chris forcing himself to curate some data. So I do think one of the big entry barriers to a lot of academic software is installing it, followed by probably loading in data in a format that it requires. So not to detract from the work done by all of the participants as well, but having raw data as well in future is going to be a wonderful result, I think. Okay, so moving on. Firstly, with the registration, we just used GitHub. You can open an issue on GitHub. It's two fields to fill in: your team name, the GitHub users that you want access, and a checkbox to say that you're happy for your code to be open source in return for potentially winning prizes. So in terms of the template code repository itself, I'm not really going to go through it, but effectively it requires you to install Surf, Sil, and CUDA on your own machine. It's probably easiest to just use our provided Docker containers, which already has all of this installed. And the only two real requirements inside the code itself is a main.py file. We already had a little framework for that. So there's a submission class inheriting from Sil, and we even provided reference implementations for a few standard reconstruction algorithms: BSREM, ISTA, OSEM. And yeah, so you're free to tweak those. Technically, even if you make a single line of code change, that counts as a submission, and you're in with a chance. And of course, if you're not happy with our default Docker containers, you can always apt pip install additional things by just adding these extra standard usual suspect files. And so when you register, the first thing I do is create a private mirror. You can't create private forks in GitHub implementation detail, but effectively only you and your team members will have access to your repository, so that none of the other teams can snoop on what you're doing. That's the format of the repository name. It's just Petric dash, the team name that you chose. And, well, of course, I have full admin access to this, so I was not eligible to submit anything, of course. No conflict of interest there. And the nice thing about using GitHub is you get to use their native continuous integration. So they have their own runners. Unfortunately, they don't have any GPUs, or at least the GPU runners, well, they cost, and plus you don't really have any guarantees about the speed and efficiency. So if two different people submit some code, they could be running on technically slightly different systems, and how do you really compare them? So all that I used GitHub for was very basic checks to make sure that the code can import, but not necessarily run. So if people submit things that are very obviously broken, they get immediately notified. The nice thing about GitHub, though, is it does allow you to bring your own runners, so self-hosted runners, as in if you have your own machine on premise, which I did. I had an NVIDIA A100 for this purpose, but you could rent machines from one of the usual suspect cloud providers: Amazon Web Services, Google Cloud Platform, Azure, or any of the others. So that's basically a single machine that is very standardized, and everyone runs on that. And if anyone pushes a tag to GitHub, any tagged code to GitHub, it will effectively run on this machine. And the important thing is it runs in a queue. So if multiple people submit code at the same time, they'll all be queued up, and they'll only run one at a time. So you're not slowing down each other's code. So the queue is sequential. So GitHub officially actually recommends you don't do this in their documentation, and it's mostly effectively because they can't be bothered to help you over here. There's of course enterprise level support, but yeah, I come from industry, so I've spent literally a decade building up a suite of pen testing and security hardening tools. So I managed to work around all of this. I won't bore you with the details, but it was fun stuff to do to make sure that the world can't hack into UK government servers. Okay, so one of the other things that we could also use our machines for is to host publicly available dashboards and well, also allow people to download the data themselves if they want to. So for that, you need a public IP. If you rent a server, it's quite easy to get a public IP. I managed to get one for the UK infrastructure, which is nice, and also infinite wildcard subdomains. So anything .tomography.sdfc will point to this IP address, which is quite nice. I set up a reverse proxy, which is just a program running on a machine that handles any web requests. So if you go to tomography.sdfc, this program will handle those requests, obviously with HTTPS, S for secure encryption. So one of the things that I host here is the data, which I probably can't open on this. Can I? Nope, of course not. Oh, yeah, I can. Okay, so this is all of the raw data available. They're all in folders. They're also zipped in case you don't want to download individual files from folders. Clearly my mouse does work. Okay, that will be useful for later. Right. So one of the things during the competition was the live leaderboards. I'm probably going to crash something again if I try this, but hopefully this will work. Might think about loading. Okay, so we hosted everything on TensorBoard, which is a standard thing from the machine learning world. But so you can look at the RMSE of the whole object, for example. There's all of the teams and all of their different algorithms submitted over here. So the naming convention is the team name followed by the name of the algorithm, followed by the name of the data set that things are running on. So you probably don't want to cluster the whole thing. There are a lot of annoying things that are defaults in TensorBoard, so you have to change this to relative to see the wall clock time. You have to undo smoothing. I have no idea why they include smoothing on a quantitative tool, but you get a nice impression if your submitted code is immediately failing. You'll see it's failing over here. Is it meeting the thresholds? That sort of thing. Come back. Full screen again. So the final results are also available in the same machine online, and we have summarized tables of those. I'll try that. Yeah, of course. It's not like I set this password 2 seconds ago. Okay, so these are the tables for each individual data set. So here for the first table, the algorithm that was running the quickest took about 7 minutes to meet all of the thresholds. That was our requirement. You had to meet all of the RMSEs and all of the volume of interest thresholds, something like 1% a normalized root mean squared error and 0.5% volume of interest absolute error of mean errors, which was quite strict. But there was also, like Chris mentioned, we ran this a few times to get a median, and this is the estimate of the standard error of the mean over here. And if that didn't work, so after 1 hour, there was a timeout and you still didn't manage to meet the thresholds, the fallback was to rank by the average distance away from the thresholds. So sometimes you still get slight negative numbers because on average, most of the thresholds were met, but maybe one of the thresholds wasn't. So that's why some of these distances away are still showing as negative. So these are all of the results that you can drill into in the interest of being open and fair. They're all online, and you can inspect them. And in case you find a bug, you can always challenge our results. In terms of the final leaderboard, I won't quite scroll down yet. I'll leave that for later for the awards. So I think what we should probably do next is cover what the teams individually have done. So final word, we probably will host a similar competition in future. Since most of the infrastructure is now set up, we'll probably be a lot more slick and smooth and hopefully have more interesting data sets to deal with. And yeah, do check out the GitHub repositories if you're interested. So yeah, who's next?